Welcome you all students. Fourth day of bridge course conducted by Department of Statistics on correlation and regression and its application using R software. Uh, Good morning to all. I hope everybody is doing well right now. And we have a mixed audience, FYSYTY. So before I start session, let me know whether I'm audible to all. Okay. Yeah. Thank you. So let us begin. So as a topic, is based on correlation and regression and its application using R software. This is the very major, or I will be say the very vital part of the statistics, because here we do the modeling case. We do the modeling part in the statistics, which is widely used in different applications. There are different applications. Okay, but as I told, we go with the very basics because we have all mixed audience. So I will not consider more of area of this, but you I'm assuming that every student knows very well the concepts of, at least basic concepts of correlation, regression and everything. So using those concepts, here we can observe these charts. Here we can observe these graphs where we can understand the strong relationship is mentioned in the left side, where we have on x-axis we have a you can call it is a independent variable, y is a dependent variable, and the graph is from left corner to the right corner. Okay, so when this structure, or this is, you can call a scatter plot. Okay, this graph is called as also scatter plot, where you can observe the points from the left corner and it is reaching to the right corner. That means there is a strong relationship, and which is actually positive relationship. Okay, but if you just look at this one, this is also strong relationship, but it is from right corner to the left corner or left top corner. Okay, so this is also strong relationship because majority points are on the line. Similarly, here we have a weak relation where you can see this is a particular line and there are different dots which is away from the points. Okay, so this is why called weak relationship, because majority points away from this line, and if you just measure this distance are very high, where this distance are very far from this line. Okay, this is very near to this line. So whenever this distance are very near to the line, that means there is a strong relationship between x and y. You can consider so many examples. We will consider the examples maybe later on. Okay, but you have to understand the pictorial way to understand the graph, because before this bridge course session, I have a meeting with DLL department, where all students have joined, and we have seen like there are several activities done under the DLL and NSS and CC, basically in DLL. So there we using the, I will be say 80% of our statistics, 80% of our statistics in DLL department, where we collect the data, we organize the data, we show them in the different tablet form, we do the analysis, we give the report. So that is all done under this statistics. Okay, so I will be say statistics is not only used in the like very small part, it is used in everywhere, like our daily department, which actually I was not knowing. So once I had joined that session, then only I get to know whether it is applicable in daily department also. And so as I told, now we'll talk about any project, lot of applications under this project, but how to use it, we have to understand the data. See, the very important concept is that how do you analyze the data? how do you analyze the data? You have to understand their variables. Okay, so this is a brief about the correlation. So correlation, what it means, correlation, it's you the just linear relationship. It's very important. The term is linear. It's why not it is quadratic and other thing, because the Carl Pearson has a given only relationship between the two variable, which has to be linear. Okay, so make sure that it's give just the linear relationship between the two variables. Now there's some concept introduced by the regression. Okay, so as I told, regression is a modeling technique. Regression is a modeling technique. If I have given one variable, then how you can predict some variable based on the given variable. So it is something like we have to find out the dependency between the variable. Okay, so how you can get one variable based on the other variable, like that. So obvious in your mind you may understanding, yes, there's some variable which is dependent and some variable which is independent. Okay, so we need to be discuss two things in this scenario. What is that? One, this is the equation, y is equal to a plus bx, where we denote y will be your dependent variable, x is your independent variable, and that is introduced by the Galton 1911. Okay, the first applications they have given by the Galton, which is actually applications of your regression. Okay, so what is a regression? Regression is just modeling technique. You can model the given data. Okay, you can say, but modeling the technique is not easy technique, because you have to learn so many things. Okay, so this is something like if you are interested in the modeling technique, then you must know this is the foundation of the modeling. Okay, and later on we will discuss this all. Okay, so type of variable. So we have a two type of variable always in the modeling. Remember, any modeling you do, any modeling, what में जितने भी modeling है, we have only two type of variable. One will be dependent variable, one will be independent variable. Okay, now dependent variable and independent variable, we will take the example and then understand why it is called dependent, why it is called independent. Okay, so I'll just for a being can just leave it as it is. You understand what are the variables involved into the modeling. So modeling, we have dependent variable, we have independent variable. Now the basic structure of the model is always y is equal to, you can understand this, yi is equal to functional form of your x and beta is your parameter, plus some error. Now this you can assume y is equal to a plus bx also. That is also form of model, but that was simple model. This is I'm writing terms of general model. If you want to write any general model which is exist in maybe in the world, so we have these type of model. So yi is equal to f of xi comma beta plus epsilon. Now this is the functional called function. Now this function can be anything. If this function can be anything, this function can be linear, this function can be quadratic, this function can be logarithmic, this function can be exponential, anything can be this function. So that's why I told it is general. That's why I told it is general. Okay, and where you have to understand this, yi is always a dependent variable, f is a function, and xi is your independent variable, and beta is your unknown parameters. Pi is called as error. This all description is given here. This all description is just. So you have to understand this each terminology. Okay, you have to understand this each terminology, how it is used. Very basics. It's nothing related to, like you have studied this all. So assuming you are knowing that, but only the thing is we are using little bit different parameter, so that you will be slowly you will be know very well. Okay. Now this is a major part of statistics. I would say, if you understood this part, then definitely your statistics is going to be, means I would say, rather than your analysis, or you can say the understanding of your data become a very excellent. Okay. So I hope this is a majority students are already knowing, assuming because you're from statistics background. We have two types of data. One will be the quantitative data, one will be the qualitative. I will not going to describe much about this because I know you are not, everybody is know very well. So if I go on much talking about this, then we become bored. Okay. And under this quantitative type of data, it's further divided into the two subcategory: continuous data and the discrete. Continuous data means you have an infinite option like age, weight, blood pressure, etc. etc. Similarly, if you have the discrete data, that means you have a finite shoes, number of children. So I will not say I have 1,000 children, right? I will be say, mean you must have the finite number. Discrete means the finite number. Continuous, infinite. Weight can be, see, if I'm saying weight can be varying from, let's say, 40 to 90. Any number can be between this 40.01, 40.0, any number. So you have an infinite option. So if you understand these two type of data, first of all, under quantitative. So under quantitative data, we have a continuous, and similarly, we have a qualitative data. We have a qualitative data. Under qualitative data, we have again two category: ordinal and nominal. Ordinal and nominal. Okay. See, might be the majority students, we have not worked so much on qualitative data, but definitely you worked on the quantitative data, right? So we can, I will introduce a few of the terminology, so my TY students can more explore about those things, because that is going to be help in their further studies, like in MSc and other maybe data science courses. That is all quite important for them. Okay, so that's why I told it is a mixed audience, so I have prepared a little bit for them also. It's not something like they have studied. Similarly, we have ordinal data and nominal data. Okay. So under ordinal data, your data has to be in hierarchy. It should be in order, like pen severity, satisfaction rating. Okay. So this is all basically you are giving some order, like how much you are strong about this decision, how much you are satisfied with this brand. So I will say strongly satisfied, weakly satisfied, good, very good, excellent, like this. Okay, so those type of things will be always a ordinal data. Okay, then we have a nominal data. In nominal data, we don't have any hierarchy. It can be yes or no, it can be eye color, it can be dog breed, it can be type of blood, it can be you can say eye color, I have already mentioned, male, female, like that. So those data pass, fail. So there is no hierarchies exist in our data. So these are basically types of data which is quite useful in the modeling purpose, because see, we didn't employed more understanding about the data. Okay, so far let's move to the next slide. You will understand slowly. So if you look at this data, means brief about the correlation relationship, correlation and regression. There's some property exists, or I will be rather than say relation. So relation between x and y. I hope you are understanding this notation. R of xy is same as R of yx, right? Because the correlation between height and weight, and the correlation between weight and height, that is definitely going to be same only. So you mean to say uh, relationship between x and y and x both are same, means you will be get same answer for relationship between two variables. But what about the regression coefficient? regression coefficient means regression coefficient y on x. This means regression coefficient x on y. XY hai na, means there is a x on y is not equal to regression coefficient y. Okay, so this is the difference of under regression. Okay, so since the correlation is same, but the regression coefficient value is going to be the different. For example, if I'm considering y is equal to x square, so what is the meaning? It's a y on x. So this is the polynomial square. Okay, but if I take x is equal to square root of y, so this is become my x on y. Okay, so here I will be get the different byx, and here I will be get the different bxy. So it depends on the problem. So that's why here the regression coefficients are changed, but the correlation coefficient are remain same between the two variables. This is just note about. Now this is the very important for students. Till TYBSc, you have only linear regression. I have not included the multiple linear regression because it is assumed to be the part of linear only. Okay, it is assumed to be the part of linear only. So there are majority, I will be say, I have included actually 5 only, but there are several, which is maybe if you explore it, you will be understand. There are the linear, means what are the types of regression? We have a linear regression, which might be FY, SY, and TYBSc students knows very well. Y is equal to mx plus. See, there are different way of writing. Okay, so that's why I don't go with the notation. You have to understand y is equal to functional form of x plus epsilon. Now that functional form can be a plus by. It can a plus bx. It can be c plus mc or whatever that you can say. Okay, so that form can be changed. Just understand linearity. So y and x, that should be the linearity. Then we have a very important logistic. Okay, so when do you use logistic regression? When do you use conditional logistic regression? Polynomial. Okay, Cox, that's also called the Box-Cox transformation regression. Okay, so these regressions are quite useful. I hope this I have already covered under my FYBSc, and I think in TY also I have covered little bit of that. I don't remember, maybe in the time, I don't know, but some part of that I have already included. But definitely in FY I have included how to fit the model for this. So here only under this category, under logistic and logistic condition, I may not use our method of least square, because I have to use other method to get the estimates. But whereas under this method, linear, non-linear, even the Cox, some part of the Cox proportional hazard regression, I can use my linear least square method to estimate the parameter. Okay? Because least square method is a very famous method to estimate the parameter, and because it minimizes the error sum of square. Okay, it's minimize the error sum of square, which is a very important purpose of minimizing and getting the parameters. Now, this is a very important part when you go for any modeling. Any modeling means any analysis. I will say rather any analysis, because see, software don't know about the number which you are feeding into the software. Remember, if you feed any number in the software, it will give certain output. But before entering into output, we have to understand whether that particular data is appropriate for given method. So for example, linear regression. Suppose I have a linear regression. Okay? So under linear regression, your dependent variable should be continuous. Now I have seen so many students, they perform linear regression, but they are not testing about the understanding their data. Means if the data is even discrete, they have applied it. No, you have to understand the concept of this dependent variable and independent variable. Okay, so under linear regression, you must have your data should be continuous, which can be weight, height, etc., etc. An independent variable is also continuous, and in case if it is discrete, if it is categorical, then there are some concept we have to add dummy variable under this category. Okay, so that I will maybe I will not going to cover this part, but you can understand for linear regression, your dependent variable should be continuous and independent variable is continuous. Definitely it should continuous, but if in case if it is some variable is categorical, that is also fine. We can go for linear regression introducing some type of dummy variable. Okay, but you can go for that. Similarly, we have a logistic regression where your dependent variable is dichotomous. What is a dichotomous? It is a type of success and failure. Now see, this is a very, very important. Majority in cases, now logistic regression is a widely useful. For example, either you pass or fail. So suppose my dependent variable is pass or fail. Okay, so what are the different factor of passing will be dependent upon independent variable, like your health, like your IQ level, like your score. So suppose I'm considering these variables. So whether are you going to pass or fail, pass or fail, pass or fail. So when your dependent variable of type of this, yes or no, we have to go for logistic regression. And this is nowadays it is quite useful because see, when you go for any movies or any can say hotels, generally they ask for feedback. So you say you are agree with like all facilities or not agree. So yes or no type of data is there. So if you are agree, then you have certain way. If you are, then there are certain independent variables. So you can predict, you can fit the logistic model. I hope my voice is clear. Can you just go to chat box, just type Y if you can hear me properly. Just type Y in chat box. Can you hear me properly? Okay, good. Wait. So this is the logistic regression, which was not included in TY, but mainly it is covered in the further studies. Who is going to be studied? Whether it is data science, whether it is any artificial intelligence, whether it is you may say MSc in statistics, whether it is in the anything. This particular topic is definitely it will be there. So you can little bit understand how this dichotomous variable works and try to use the modeling of such a, because it is right now. And here also your variable, independent variable can be continuous, can be categorical. Okay, so itna dhyan rakho. Whenever we have categorical variable, we have to introduce dummy variable under that criteria. Okay? Then we have a proportion hazard regression, which is also known as the Cox regression. Usually it is used in the survival data. Means any components, like we have any system, how much time it is going to be, survive. So whenever your event is dependent on the time, then we can always use. So we can't use linear regression. We can't use logistic regression. We have to go for always the proportion hazard regression. But this is all model exists in the maybe using R, using other things. You can always use it. So, but for that purpose, you need to be study a lot. Okay. So whenever event based on the time, you can always go by the proportion hazard. Now there is a Poisson regression. The Poisson regression when I'm going to use when you're talking about the counting data. Counting data means usually when you said like the event is rarely happen, then you use Poisson, right? I hope it is clear everyone. Everyone is knowing when we use. So whenever event is rare, we can use Poisson. So it is something like, for example, the number of times a woman gave birth over the certain period of. So it's a rare event. 1, 2, 1, 2, 3, 1, 2, 1, 2. So you may find that the number 1 or 2 or 0 will be very high, right? 0 and 1 very high if you collect the data according to the survey. So it's going to be highly right skewed. It's going to be very highly right skewed. Okay. So when such a data is there, counting data is there, we can always, and basically it is whole number. 1, 0, 1, 2, 0, 1, 2 like that. So in that case, one can go for Poisson regression. So this is a very important, I would say, uh, foundation of your studies, which you can say. So this is, I have already explained you, yi is equal to beta naught plus beta 1 xi plus epsilon, where this you can call linear component. Beta naught is a, you can say, intercept value, beta 1 is a slope value, xi is your independent variable, and yi is your independent. Sorry, yi is your dependent variable, xi is your independent variable, and obviously we have epsilon, which is error. This is nothing but your, when we have a more than one variable, then it is called multivariable regression. Multiple linear regression usually called. So multivariable means we have a more than one variable and all coefficient. I hope now you can observe here we are using beta, here beta 1, but just suddenly we use here a b. See, this is regarding to the population. This is regarding to the population. So when we talk about the population parameter, we always define betas. When we talk about the a, small a, b1, b2, that means we are talking about a sample linear regression. Remember, sometimes they ask in the YY, what is the difference between these two? Understand this concept. Okay. So when do we have a sample? Means actually I'm talking about a sample linear regression, sample linear regression, sample multiple linear regression. Because we have a sample, based on that we are estimating these parameters. Okay. So what is the aim of pure simple linear regression? You have to predict the dependent variable from independent variable, and it gives the linear degree of a linear relationship between the variable. But this is the important part, which we have not used actually in a level. But understand, we are going to use these assumptions using our software, but not all. It is not possible to check for all, but which you can understand, that we can cover in this. So what are the assumptions are there? So the very important assumption, your dependent variable is continuous. So I have already explained you, your dependent variable has to be continuous. And your dependent variable is all assumption. It is a very important. Okay. You know this assumption. And independence of observation, how Just give me 1 minute. I'm sharing the screen. Just give me one. So before I will be begin, I have just shared today's attendance sheet, which is now nowadays very important. Because for doing this all documentation part, it is very important. Okay, so you just fill. You can take a 2 minutes break between this, and then you can just fill it this. Okay, so by the it's very small detail is there, just your name and the basic information. Just fill it this, then we can continue conversation. So just take 2 minutes and finish this, then we can our continue session. Let me know in chat box if you're done. Say why. Put why if we have filled that attendance for today bridge course. So there are around 42 students. So very nice to see all of you. And those students have uh, joined this that principal interaction wala meeting. I think sir is going to be explain about the admission process. So I will finish before that. So you can join those sessions. That is also important because some if you are done, you can go to chat box and write down why. So that we should have some idea how many students have filled feedback form or feedback rather than average attendance form. If anyone having any problem with opening, and then let me know. See the admission process, it is not started. Okay, so everything will be uploaded on our site. Okay, don't worry about the admission. It will be very soon. They will upload video. What is the process? Everything will be uploaded on our site. Okay, don't worry about Akash. I know students are like more enthusiastic to take that mission in the subject of all math, stats, physics, chemistry, everybody. Okay, so I hope majority have it. So let's begin. Let's begin. Let's continue with the. So we were discussing about the assumption. Okay, so assumption, if I'm talking about, we will just consider few assumptions. The first assumption is very important. The variable y, which is nothing but your dependent variable, that should be a continuous variable, and it is always a normally distributed. Dependent variable is always normally distributed. So you know what is a normally distributed. So data should be normal with mean 0 and variance sigma square. See, mean mu we say and variance sigma square say. That is a basically term we use. But in the case of regression, we have to always check whether the mean is coming 0 and the variance which is there under among the dependent variable. I will say rather than dependent variable, due to independent variable, it is always a sigma square, which is a constant. There are some conditions they have given. How do you analyze? How do you analyze whether the given variable is dependent and independent? See, sometimes students get confused. Not students, everyone. It can be happen with anyone, because understanding about the dependence or dependent variable, it's not a very easy task. If we have given real life data, we have to see if the objective is given, then it is simple to understand. It's very simple. But when you have actually collected the data, you have put in the form of raw data, put in the form of Excel, then you are now analyzing using this variable. You can predict like what you can predict. So getting dependent independent quite easy, difficult task. Okay, so we have such a method. We have such a you can say backup to understand how you can obtain the dependent variable independent. That we will see using the RStudio. Then you have another assumption which is called linear relationship. As I said, if your data is linear, then only I can use linear relationship. I can use simple linear equation. Otherwise, I won't be. So if assumption is not followed, one may go for log transformation. One may use inverse transformations. Okay, that also happened. But I would rather say, instead of going with that, you may try out some other method, which is maybe logistic, maybe some other method like ordinal regression is also. But again, I said it depends upon the data. Okay. Now there is another assumption. It's called homoscedasticity. You know there is error term, right? If I show you the error term, there is an error term in the problem, EI. Okay. So if I'm talking about the homoscedasticity, so the error term does not vary as much as the value of predictor variable change. If my predictor variable changes, so there is slightly change in my error, but does not vary much. Means I will be say either rather than that, error should be minimum. Okay, error should be minimum. And the last assumption, which is no significant outlier. So in our data, outlier should not be. I hope you know the meaning of at least outlier, the data which is very, very, very away from your cluster data. I will say means cluster data means if we have the majority of age group lies between, let's say, 20 to 30, but some data, let's say 50, 60. So these are 2 points which is not actually belonging to my group of 20 to 30. Okay, so they are little bit away from my data. So I will be say this is some maybe outlier. So it can be very less, it can be very high. Okay, so when we have a similarity in the data, then I will be say that is actually my pattern. Okay, I will be take this with the help of. So this is called basically linearity. You may understand linearity means your data is, you can observe that this is in the form of linear. This is also linear. But if you look at this data, this is not a linear. It is something like you may call it is curvy linear, or you may call, if I extend this little bit up and down, you can exponentially distribute it like. So rather than I will say linear and non-linear. So if it is linear, then I may use linear regression. If it is non-linear, I may not use linear regression. I have to use another technique. Now, if you look at this data, there's some outlier which is very high. This is also outlier which is very low, near to the line. This is very away from the line. Okay, so this is also happen in our data always. Remember, even if you do very systematic way of data collecting everything, but still there exists outlier. Okay? So one can try to remove this outlier. There are several methods. Okay, so whichever method you feel it is appropriate, you can use it for removing the outlier. So as I say, homoscedasticity. So if you look at these two graphs, your pattern is like from this bottom to it's moving very upward, right? It's moving very upward. So that means it is from bottom to increasing and then again decreasing. That means data is heteroscedastic. Means your variance due to that error term is not same. But here, if you look at here, it is a common. It is the simply from here to here, the distance is same. Can you look at your data is like there's some pattern. You follow some pattern here, right? You follow some pattern here. But the variance among these are remains same. Okay, so that we can see with the help of looking sometimes the graph it is not clear. So for that purpose, we have to use some of the test which we are going to use with the help of R software. Then there are several examples. I have included few of them. Like you can predict the productivity of factory workers based on their test of assembly speed score. So if any particular, let's say, if any company is manufacturing some of type of bolt, okay, or pen cap, so it depends upon the have the productivity. Similarly, the SAT score marks, exam level, and you can say fact impact. There are terms residual and error. Error and residual both the same. Both are same thing. Basically, this has to be minimum that we need to be always take care. Okay, and it should be normally distributed with mean, zero, and variance signal. This is something called no linear versus strong linear relationship. So here, if you look at, there's a no linear between the blood cholesterol level and fat intake because there is no pattern. But here, if you look at, there is some pattern, some linear relationship between exists. So one can predict the blood cholesterol level based on given fat intact. So this is something like a graph of linearity where this is particular point is nothing but your intersecting at y. This is called intercept value, and this is the slope value which you can obtain using our usual formula. This is the usual formula, which is beta naught covariance upon variance. This is we have calculated. I think we have derived, so you know very well how it is used, and one can also compute alpha value. This is the linear regression of y is equal to a plus dx. I hope this is all derivation, which is we had done it in the FI level, and we have always seen. Similarly, we have a relationship between beta and R, and this is the finally your theory part. Now we'll move to the actually real life application, how it is used. Okay, let me show you the R programming for this. I have considered two data. One, the data which is exist in our library. Okay, that is basically data is called cars data. So to understand more about the data, you need to be just type data open and close bracket. Just type data open and close bracket and just run using this command. One can use enter, control plus enter also. One can use just run command. Once you run it, okay, automatically new tab will be open, and here you have a huge amount of data which you can use for your analysis. Okay, see at the maybe meanwhile I will explain about some type of data which you can use for further coming events. Okay, so if you look at this data, we have this air passenger data, which is the monthly airline passenger numbers from 1949 to 1960. So this is the airlines passenger data. This is the BJ sales data, carbon dioxide data. So many types of data exist here. If you want to know more about this data, so what you have to do, suppose for example, I'm interested to know about the car data. Okay, so you may just type here car. Let me see. Or you can simply write here, go to help and write down here cars data. See, just type cars here. Are you able to see this? First of all, let me know. Are you able to see this screen for our window? Okay. So what I did first step, I typed here data and I have run it. So once I run it, I may automatically go to the next tab, which contain huge amount of data. Okay, and but further I am more interested to know more about the details of the data. So what I do, go to the help and type here that particular file name. So for example, because I'm interested in car data, so I've written cars. So once you type cars, you may say understand. So automatically the window will come, speed and stopping distance of cars, and they will give the distance like description. The data gives the speed of the cars and the distance taken to stop. Okay, so there are two variables given, speed and stopping distance. Okay, so when we deal with the cars data, you must understand what is the physical interpretation. Note that the data were recorded 1920. Okay, so that is a very important. This is a very old data. Now I think 100 days over. It's 2021, like 100 more than like 100 years. So we have this car data. We are using the car data, and they are given certain formats also. We have a 50 observations on two variables. You know what is a variable? दो variable हमारे पास है, and we have a 50 observations. Okay, so 50 observation, that means in terms of our language called cases. We call cases. And two variable means we have a two variables means two variables. Two variables or two factor. So what are the variables we have? Speed and distance. And if you look at this numeric, the data is numeric. Speed जो है वो numeric है, distance जो है वो numeric है, and they have given their units in foot and the mile per hour. There are some sources. So from there they have collected, means they have used those data, and this is something like they have given certain type of, you can say, programming for that. So this is the way you can explore more about your data set. Okay. And that is a very important task, because when you're going to use any of this data set, and there are plenty of data which is quite useful, and they did several analysis under that using those data sets. Okay. So now suppose you want to view the data. Now so far we have studied, yeah, there are 50 observations, there are two variables, but I want to see actually how the data look like. I will just give me 5 minutes. I will see the chat box, and I will, if you have any questions, we have it. I want to see actually how this data look like. So I have to go to write the command view, and make sure this V will be capital. Okay, view, and type your data set name, which is cars. So just run this. automatically new tab will be open, and you can observe the data speed and distance, and this is my actually data class. And you can observe there are 50 observations and 2 variables. Okay, go to the again previous tab. Now suppose you want to understand whether my data which is there, it what type of data is this. Okay, you should know the class of the data. I think basics you have already done in the evaluated courses. So to understand in the class of data, whether it is numeric, logical, integer, etc., etc., we can always go for S apply. We can say supply. Okay. S apply. So we can write S apply bracket में your set data set name comma class. So this will tell you types of data, what type of data it is. So whether it is numeric, continuous, okay, etc., etc. So they will see. So see, I hope everybody is knowing this window is called as a script window. This window is called console window. This is some part of your history environment. This is graphs, package, etc., etc. Okay, so that I have not assuming that you know very well, maybe at least the part of the data. Acha, before I stop here. I stop here. Before I continue this further commands, let me know how many students are not aware about this Art Studio software till now. Just go to chat box and type Y if you are coming to the first time, means you are knowing about the first time this Art Studio. So I will give a little bit more about Art Studio. Yes, anyone who is not aware about this Art Studio? Achha, okay. Value added course is done, I think, in the month of May. We have circulated all the notice so many times. Okay, no problem. Now it is already done. Fine. So there are few students also there. So to incorporate them also, that is also important. So fine. See, this is a software which is known as a art software, or sometimes it is said Art Studio software. There are 4 type of windows are there. This is the first window, which is known as a script window. Script window where we write the command, and below this window, which is called console window. So when you write the command on script window, when you execute it, it will display, or it will give the you may say there are third window which is right top, which is environment window, history window, connection, etc., etc. So basically this window is used when you enter any variable here, it will be coded here. Okay, so that is more about the environment window. Then this window which is right below, we have here and dealing with the more about the packages, docs, file, help, etc. So this window is also important to understanding more about the windows. So here we will write the program. Here we can understand the what would be my output. So this is very brief about the data, very brief about the software, because it is not possible to cover me There's some technical issue with the network, but now we have to face it. No problem. Okay. Are you able to see the screen now? Yes. Okay. So as I'm talking about my data set which exists in the uh, uh, R. Okay. So I'm not taking any data from outside. So this is the command data to the data, understanding more about data, which is called that means what are the type of data it is. It is numeric, it is string, okay, etc. I wanted to know summary about my data. It means the brief introduction about my data set, means like what could be my mean, what could be my median, what could be my quartiles, maximum, etc. etc. So if you look at this data, speed, so minimum speed is 4, first quartile is 12, means 25% of observations which is below 12. Similarly, 7 means above, you can say 75% of the data, means I rather than say I will say 25% of data my above that 75%. That's called third quartile. Similarly, we have a maximum, minimum, maximum, means it's a in short about your data. Means whether your data is skewed or not, very skewed or not, that also one can understand. So median, mean, here median and mean are same, approximate same, 15, 0 and 15.4. But here if you look at median and mean, it is coming, means there are difference between these distance, okay, because this is talking about the distance. Now you want to, since you're interested to know whether, how do you know whether it is dependent or independent? So let me just draw the correlation plot. So just type COR correlation and type your data set name, and this is called $sign. This is called $sign. Type your variable name here, distance. And again, so this is my first variable and this is my second variable. So whenever you type any variable, we have to always write the data set $sign your variable name, which was my distance. Similarly, we have a car and we have a speed, right? So just find out correlation between these two, which is coming 0.8. Means there is strong relationship between speed, or I will say distance, stopping distance and speed of cars. Now I have explained you the correlation between X and Y and YN. So let me just find out cars. Suppose I'm taking the speed first, comma, cars. Then I'm considering distance. Second variable, see automatically when you type D, it will come here. So you can just select and just run it now. Just check whether this is coming same one. So correlation between X and Y and correlation between Y and X are same. The correlation is not going to be differ between X and Y and Y. Okay, so just understand. Suppose I want to plot this. I want to plot this, assuming this is my X axis, this is my Y. Okay, so we always write P of, I will be say plot of X comma Y. We always write plot of X comma Y. So when you plot this, where X axis पे you have an independent variable, Y axis पे you have a dependent variable, then how your graph look like? Let's see. So remember, when you plot anything, this portion will be more. This this portion will be more. Otherwise, na, they will say the size is very small, etc. etc. They will mention. Just plot this, execute this. So this is the basically graph they will give. So if you just look at this data, you can find some pattern here. You can find some pattern here. Okay. So pattern means when my distance is stopping distance is increases, my speed is also increasing. So one can obtain the speed. One can obtain the speed based on given distance, right? So you have to predict that. You have to understand the variable which is dependent and independent. Okay. Since it is simple because we have two variables, but it is going to be difficult when you have more than two variables. Are you getting my point? So understand that concept that we will actually see in the, maybe I'm going to use another data set. Now, as I told, we have to understand the variable which is dependent, and we have to check for the normality. So dependent variable is my now speed, and I want to check whether the speed, variable speed, is normally distributed or not. For that purpose, we have a Shapiro test. You have to use for Shapiro test to check whether data is normally distributed or not. Okay, so here you have already studied in the previous beach course, like testing of hypothesis. We have set null hypothesis as well as alternative hypothesis. So remember one thing, students, whenever you do any testing, you have to be specify your null hypothesis and alternative. Remember, software will not give you the H0 and H1. We need to be decided. Okay. So Shapiro test, Shapiro will normality test says your H0, which you are assuming, it is also known as null hypothesis, your data is normally distributed. Okay, remember. Now, how do you remember this? You know what is the concept of null hypothesis. Null hypothesis which we assume it is true, but actually it is not. Actually, it is not true. We assume it is true. So I'm assuming that H0, that means my data, that my dependent variable is a normal distribution, versus dependent variable is not normal distribution. Okay, so that hypothesis you should always define. So when actually you write report, when you write in the form of report, we have to write down all those details, at least H0, H1, and then based on that, you have to specify p-value. That's it. वो सब पूरा details देने की जरूरत नहीं है, because our aim is to be whether this particular assumption is satisfying or not. That is our aim. That is our aim. Fine. So Shapiro test will tell you whether your dependent variable is continuous or, sorry, dependent variable is normally distributed or not. So if you look at, there is a very important concept called p-value. So based on this p-value, we have to state our conclusion. We have to state our conclusion. So what I said, our H0, data is normal distributed. What is your H1? Data is not normally distributed. But remember, students, you have to understand this criteria. What is the criteria? P-value, if less than alpha value, then we have to reject the null. Remember, I don't have actually pad, so I'm just writing with the mouse. So it can be like this only. Reject H0 means you have to reject the null hypothesis. And this alpha, by default, I'm considering 5%. Assuming that there is a 95% confidence interval, 5% only error exists in my data. So obvious, if you look at this, it is 0.45, means around 45%, which is always more than alpha. That means I'm not going to reject null hypothesis. That means I found that my data is normally distributed. Is that clear or not? Let me go to chat box whether you understood Shapiro test or not. Just type why if you understood. If not, then write time. Go to chat box, write down why if you understood. Or if you want to repeat me that p-value, that etc., then also you can. If you understood, simply why. Otherwise, you may write it. So only criteria if to understand p is less than alpha, means your p-value which is calculated using software is lesser than your level of significance, LOS, which is known as alpha, which is also known as the maximum probability of typos error. That different terminology which we are going to study in further studies. If this condition satisfies, then we say it is reject the null hypothesis. Otherwise, we have to accept. So, यहाँ पे we have greater. That's why we will always return. Return means return means we have to accept. We have to accept the null hypothesis. That means your data, or I will say my dependent variable is always normally distributed. Yeah, that is also fine. See, some students suggesting that p-value is lower than null hypothesis. We'll go if p-value is higher than acha. Great. Correct. So I will be say rather than if higher in terms of statistics, higher p-value, that means there is significant. There is no significant. Right? Higher means there is no significant. Lower means there is significant. This is also very nice shortcut for remembering. If p-value is low, null will go. Very great. P-value is low, null will go. If p-value is high, null will fly. Very nice. Highly very nice. Sahili is our TY students who has given this particular rhyming, you can say. Just remember, this is also very nice. If p-value is low, null will go. Means null hypothesis will reject it. But if p-value is high, then null will fly. Means you can retain that. Good. Fine. So let's go to the next part of that. So now that means your dependent variable is normally distributed. Okay. And there is a linearity. There's a linear relationship between x and y. I may apply linear regression. So linear regression ke liye we have to fit the model. So how we define model is equal to LM means linear model. Your dependent variable, which is your y, and this is your independent variable. So I will write in terms of this. So how we write? This is nothing but LM means your linear model. Bracket may y is your dependent variable. This is an approximation sign x, which is your independent. Remember, this is the model which you have to always understand. So first, it will be your dependent variable, and this is your independent. Usually write now y is equal to a plus bx. So pहले dependent variable always, then independent variables. Okay. So remember, we have to write like this. So just execute this. So this is no error is occurred here. That means everything is all right. Then I want to know about my model. Means what is my beta naught, what is my beta 1, etc. So just click on summary. You will find this details, and that we have to be interpret. See, just running this program and getting that output, it has no meaning until unless you can interpret. Okay. So our overall aim is to be understanding your output, not just executing the output. Okay. So this particular call will represent about your model, means how you fit the model. Formula is nothing but your dependent variable. Approximation sign to, or you can say tilde sign, you can say dependent variable, independent variable. Then we have a residuals here. Residuals means your error. Okay. So it is the minimum value will be this much, maximum value will be this much. Okay. The very important part is here coefficient. And here, if you look at the coefficient, we have your beta naught. Beta naught is your coefficient, which is nothing but estimate. Estimate means it's a, you have estimated the value of unknown parameter, which is nothing but your beta. Similarly, we have below, we have here cars $sign distance, that is your beta 1, and the estimate is 0.165. And if you look at this particular value, okay, before this, I will just execute once again. I will just execute once again, because here, if you look at the p-value goes down. Okay, why it happens? Because there were no more space here, but now it is more space. So I will again put run and model. See, now you can observe the p-value comes here. Okay, so this is just matter of space. So the space nahi rahega to automatically niche jayega, but it is same output. So if you look at this particular value, which is nothing but your, this particular value is your beta naught, this particular value is your beta 1. Okay, so y is equal to, we have 8.28391 plus 0.16557. Okay, so this is my speed. So speed is equal to 8.28391 plus 0.16557 distance. Okay, and if you look at these two variables, this is a standard error which is very less. So due to this standard error, it's very less, 0.001. Even this one is also less. If it is more than like 3, 4, 5, you can, means there is some problem with my data, means variability exists in my data. This is t value. Either you say t value or you say z value, both the meaning is same because sample size is greater than 30. So these are approximating same as z or t. This is actually the part which is the t value. Okay, so probability that my t value greater than extreme value is nothing but be called as a p value, and based on this p value we have to interpret whether my distance is significant in the model or not. Okay, whether my distance variable is significant in my model. But if you look at this data, there's something called star is here. 1 star, 2 star, 3 star, 1 star, 2 star. If you look at this star, is also there's mentioned some star here. Are you getting my point? So these stars, that means they have tested at this percent of level of significance. If it is 1, there is no value. If it is 0.1, there is dot. If it is 0.05, 1 star. If it is 0.01, 2 star. If it is 0.001, that means there are 3 stars. So actually, the model they have assumed at 0.01%. That means 0.001. Okay, 1% how we write? It is 0.01, right? So 0.1% means this. So if my model is true at this percent, can it be true at this percent? Can it be true at 5%? अगर lower पे significant है, So can you say it is true at 5%? Yes. Anyone? Think it, little bit think it. If I'm saying it is true at 10%, then obvious it will be true at 1%. It will be true at 5%, right? But if it is true at 1%, will it be true at 5%? Not necessary. Not necessary. Okay. Understand this is sometime very important and a very logical question. Very logical question. Sometimes it is asking that. If my variable is significant at 10%, तो क्या वो वेरिएबल सिग्निफिकेंट होगा 5% पे? Yes. अगर 10 पे सिग्निफिकेंट है तो ऑब्वियस 5 पे सिग्निफिकेंट. But if it is significant at 5%, will it be significant at 10%? Not necessary. Okay, so understand this terminology. But anyways, this p value is very 0.00000 means 12 time into 1. So obviously it will be lesser than 1%, 5%, 10%, 20%. So this is a significant. Okay, so this is the way you can always write down the model. Now there are very important here they have mentioned about just show you this details. What is that? If you look at this data, multiple R-square value. This multiple R-square value tell you about how much variation due to independent variable is explained to dependent variable. So how much percent of the variation in dependent variable is explained due to independent variable? Means 55% of variation in speed. Sorry, 65% of variation in speed is due to distance. Means my model is good. My model is good. Okay. But suppose I have more than one variable. Speed के बाद में suppose मेरा some other variable, let's called age of that particular car. Suppose I'm considering one more variable, age of car. Okay. So in that case, you always go for adjusted R-square. Remember, don't go by multiple. You go for always adjusted R-square. Okay. So when you have a simple model, one independent variable, you can always go for multiple R-square. Well, more than one, then you can always go for adjusted R-square, because it will adjust according to the included variable or excluded variable. Okay. And this is a regard. Again, it is approximating same value. So this give me basically, if you look at this data very thoroughly, there they have used t-test. There they have used t-test, but here they have used f-test. Abhi dekho, this is all basics which you have to understand when you studied theory. Okay. Okay. When you studied theory, then you can understand. So based on this value, you may say talking about overall model is significant. Okay. So I will just be the board, not much about this detail, but based on this value, you may talking about overall model is significant, whether my overall model is significant or not. Okay. And based on these values, p values, you may actually talking about your variable. So here in this case, I'm talking whether my distance variable is significant. But here I'm talking about the overall model. Okay, overall model is significant, and based on this variable, I'm talking about individual significant. The individual variable is significant or not. So this is the two criteria you have to always understand. Okay? And also R square value. If R square value, I will say 30, below 30, so model is not appropriate. Okay, it should be more than, I will say, rather than 50%. Ideally, if it is very high, then model may be the overfitted, but usually you may say over the range of 40 to 66, 65, 75, it will be there. So just take care of that. Any question, anyone so far? Let me know first of all if you have any question. Otherwise, we will go with actual some type of data. So this is the data which is inbuilt. Okay, the data which is inbuilt. Now we'll work on actual data, means actually some type of examples, so that you will understand. Any question, anyone? If no question, type Y in the chat box. If there is some question, you can ask or you can put in chat box. So can we go ahead now? Type Y. You can go ahead with this. Hardly 10 minutes more, not more than that. Okay. Just again. So now we will work on this data. So before importing the data, you must understand about the data. Okay, so I'm just sharing that data first with you. Check whether you can read data properly. So this is some example. The company has several measurements for students in their classes related to their nutrition education program. So it is basically the data based on the nutrition education program. Okay. So what are the variables they have recorded here? We have a grid, we have weight in kilograms, we have intake of calories per day, we have daily sodium intake in milligrams, we have a score on assessment of the knowledge gain. Okay, so these are the variables 1, 2, 3, 4, 5. So we have total 5 now. 1, 2, 3, 4, 5. Correct. So we have total 5 variable, and I have the data with me like this in sheet 1. This is my data. Here I have included also gender. Okay, gender was not there, but I have included gender. We have a grade, we have weight, we have calories, we have taking sodium, and what is the score? Okay, so if we have recorded these data, we have entered in the form of Excel. Okay, you might be have this type of, so when you do any collection related to education program, you must have the variable which is maybe grade, maybe weight, maybe calories, maybe sodium, etc. And what would be the score? Like if you're studying properly, if your weight is normal, if you're taking calories, okay, if your weight is very high, would it be affect in your score? No. If you're taking calories, would your score will be changed? May or may not. Okay, it happens, like I don't know, maybe it will affect. So I'm not sure about my event whether what would be the dependent, what would be independent, but definitely score means I can score more based on the given variable. So something logic in my mind, okay, chalo, let assume the score. Okay, because based on the score, you can decide your grade. So this is some data we have. Means you have to understand the data. The my means to say, like within a 1 minute, you can't understand the entire data until unless you can uh, go deep into that. So that data I have, how so you have to save this data in a form of Excel. You can save as, and remember there may have some another Office version, so you have to always save it in a version of 97 2003 workbook. Okay, if you simply use this Excel workbook, it's a very old version. So you have this version, you have to use this, or you can use CSV file. Okay, both will work. So I will rather than I will suggest you can go for this one, because we have a several way to import the data. We have a several way to import the data, but the easiest way you can go by this import data set. Okay, so just click on import data set, and there is an option called from Excel. There are so many options which is not used for us, but I can use for from Excel. So click on from Excel, browse your data where it is now. I have, you can save it on desktop and save it on desktop. So I have the book 3 data, open it. Now make sure one thing, this is my data. So when you import it, the data look like this. There are more important functions here. Sometime now you have this sheet 1 data. I'm interested to get sheet 1 data. I'm interested to get sheet 2 data. Now sometime you feed the data in sheet 2. So you have to select the data from here. Okay. So if I'm just clicking sheet 2 data, see, it is not showing, but by default I'm considering the sheet 1 data, because it is, or you can keep default option. So here, if you look at, see, I have changed according to that is changed. Okay, so if I'm just selecting again, if you say by default, it will assume sheet 1, but if you say sheet 2, then according to that it will change. So just click on import, just click on import button. If there is any error, it will show you the error in console. If there is no error, automatically new tab will be open and your data will be recorded. Remember? Acha, I have not shared the this one. Okay, sorry. Yeah. Okay, I'll repeat it. Just so what you have to go, just click on import data set. Go to. I hope now this time you can able to see the R window. Go to import data set. Click on from Excel. Okay, select your file, which is book 3. It will retrieve your data for preview. So if it is okay, then it will show you the preview. If it is not okay, then you have to be checked properly what is that. So what I was talking about here, sheet. By default, it is coming the data, but sometimes you have save your data in sheet 2. So यहाँ से जाके आपको sheet 2 select करना पड़ेगा. Remember. So sometimes see, in one of the workshop, I found that like usually we have a habit of typing in sheet 1, but actually sometimes we are using sheet 2, so students get confused. So you can always take by default sheet. So just click on import, automatically new tab will be open and you can observe the data. Okay, that is all easy, so that I'm skipping the things. I'm just going to the command. Just click on plot and okay. So this is, you can, I'm coding, this is for A is my book 3 data. A is my book 3. Click on S, apply. You will be understand more about your data, whether data is numeric or etc etc. So if you look at this data, gender is numeric. See, gender is numeric here. I have coded is 1 2 1 2 1 2. If I write MF, 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 male, female. So by default, it will assume string. Remember, okay? Since I have coded 1 2 1 2 1 2, it is numeric. So I told you, na, software ke paas dimag nahi ho. It will give some data, it will give some out, but you have to understand. Okay? Then you can take summary about your data, means it will be like your all basic descriptive statistics. You can plot of this data. See what the message is coming here. Margin is too large, right? So we have to plot this data. See, you got this here. If you look at this data, you have got this correlation between A and B. But see, interpreting these values are very difficult. If you look at here, abhi dekho, gender with gender is, there is no correlation, means it is always 1. But gender with grade, there is some correlation exists. Gender with weight, some correlation exists. So actually, I don't want to compare this gender का comparison nahi karna, because I'm going to be use continuous data. So gender is not continuous data. So compare grade with gender. Sorry, grade with grade, it is 1. Grade with weight, you can understand how much it is correlation there. Grade with calories, positive correlation, strong positive correlation. Grade with sodium, again is very strong positive correlation. And grade with score, very strong negative relationship, very negative relationship. You can look at this data. So look at this data also, one can obtain this. No, means something wrong relationship happened between the grade and gender and weight and score, etc., etc. But strongly relationship between grade and this thing, or score with grade. You can take score with grade, score with weight, etc. But you can interpret this at certain extent. But if you just plot this data, you'll be understand better than that. I'll show you this. I will just scroll this little bit up and down, then I will run it. Okay. See, otherwise, see, if I do like this now, what message is coming? The figure margin is too large. Okay, so remember, we have to give the appropriate space for that. Now run this, just run this and see what the message is coming. Something is, no, this will not. Just use this. This is pair. Yeah, just pair of a data. See what you can analyze using this data. I will just share this. See, there's some relation. If you look at this data, some relation exists. In some pattern you can follow. But if you look at this data, can you see it is random? This is all random. Means one can observe that this is the score. The score is dependent. Score is dependent variable. Are you getting? The score with the variable sodium, score with the variable, you can say the variable you have, grade, etc., etc. So scored with weight, no relation. The score. So here, if you look at some pattern means some relation is there, some linear relation is there. So looking these data also, one can identify which variable is dependent, which variable is independent. So here, if you look at score data, so score data is this and this. So it is symmetric, na? Itna portion or itna portion are same, triangular matrix. So this is my score data. The score is actually your dependent variable, and based on that, one can obtain their grade, weight, etc., etc. Okay. So one way to identify the dependent variable is this. Okay, so I will just put the model number 1. Under this, I have a score, my dependent variable, and rest I have assumed my independent. Okay, So I will just run this, and now I will check whether which one is more affecting to my model. Check. So if you look at this grade, I'm just going to directly the first of all, the first value I'm going to check is this. सबसे पहले check करूँगा मैं R square value. This is called R square value. But I'm going to use adjusted R square value here because I have a more than one value. Okay, so I will just keep this. I'm going to use adjusted R square value, which is 54%. So 54% of variation in my score will be explained by grid, weight, calories, sodium. Okay, so first I will tell this. Second, this is my first point. Second point, I have to explain about this overall model. This is the overall model. So under overall model, I am getting the significance value, which is 0.00007 time and then 3.24, which is lesser than 5%. Alpha is 5%. So I'm going to reject the null hypothesis. What is the reject null hypothesis? So how we define? There is no significant. There is insignificant or no significant versus there is significant. Means overall model is good fit versus overall model is not. So there is significant. Means I will be say that overall, since it is less than 5%, I will be say that reject H naught. That means model is significant. That means overall model is significant. How did conclusion? Overall model is significant. Now, since overall model is significant, so on the basis of which variable it is more significant, so I have to check for individual test. This is my, you can say, beta 1. This is my beta 2. This is my beta 3. This is my beta 4. Okay. So if you look at this variable, this is less than 5%, but other all greater than 5%. So due to only this grade, so only grade is significant, whereas these three variables are not significant in my mind. Okay, so you have to check this variable, which is usually called t-test, which is also known as individual. This is the individual test we did it here. Remember, individual t-test. I hope you know the t-test at least for S1 t-test. So model is significant. So we will include under my model only those variable which is significant. So score is equal to beta naught, which is coming 52.6620 minus 6.8685 beta 1, which is your grade. Okay, rest variables are insignificant, so I will close from the model. Okay, so this is my actually fitted. Okay, so this is the conclusion we have to give, but make sure that we didn't use the assumptions. So I will just give a few assumptions. Just 2 minutes, it will be get over. So to checking the assumptions, we have to use this library LM test. Okay, we have to apply the BP test for checking the model is significant or not. Okay, so overall model, whether it is data or not. The Shapiro test used for normally distributed. Okay, so this basically again, if you want to check whether the model is significant or not, one can also use studentized Bruch-Pagan test. Okay. Then there are plot is also there. With the help of plot, also one can check whether heteroscedasticity is present in our data or not. One can check that also. That is all basically or higher version things. Okay, once you run it now, it will display in the console, and we have to enter it. By default nahi hota hai. Enter it, just click on the console and just enter it. So you will be get some plot here. This is called residual versus fitted plot, and it will show you whether your data or error is normally distributed or. So if you find some pattern, if you just find some pattern, and if you look at this data, approximate, it is an error, okay, but still there is some point which is away from the data, like cases number 17, cases number 21, or I may say 26 is near to that value, okay, but this pattern, if you observe, it is nearby same, so we can assume it is approximately normal. This is a one way of checking the residual plot. There's another plot, studentized residual, whether your data will be normal or not. So as I told, almost all the data in the normal, but where some points are very away from, like number 17, number 26 and 21, they're very away from that. Okay. So this is the another way of checking that. Then they have a studentized location. This is also same type of, only we have checked for the last, which is basically studentized residual plot, and you can get about actually data में आपका outlier exist है कि नहीं. So if you look at these two line, based on these two line, like 1 and 0.5, you may observe whether outlier exists or not. So if the points, or you can say distance point, if that point is after this line, actually we can consider point after 0.5. If I'm considering after 0.1, that is more serious. If after 0.5, if some point is there, we can assume there's a little problem in our model. But if it is some point after the 0.1, means above this line, above this number 1, then there may exist, means residual having some problem, and error is there, means hook distance is there, outlier is exist in our problem. So in that scenario, we have to remove those points and you have to run the entire model once again. Okay, so for this model we don't have any like genuine problem, but remember, this is the way we can always go with the analysis of your regression model. So checking the hook distance is a very important, that says whether the outliers exist on our data, and after one, if there's some point, the more serious about your model. Okay, but if it is above 0.5, still there is problem exists, but make sure that if you remove that point, it may happen that your R-square value will be get affected. So that is statistician job to check whether we have to include or exclude. But as I said, after one, that means more serious about the point. Okay? So just take care of this point value. I think this is all about your today's base. Any question, anyone so far? I have done from my side. If you have any question, you can ask. Or you can put in chat box also, no problem. Now I am available. Yeah. Any question, anyone? I think this is all about your linear regression. So you can I will just take 2 minutes for coming. Yeah, anyone having any question? Anyone having any questions, you can ask. Otherwise, I will just take 2 minutes and then we will stop. So the Department of Statistics is very soon going to be announced about National Statistics Day. Okay, so those who are in FY, SY students, they can join this activity. Under these activities, we will provide you the data, which may be the real life data. Okay, and you have to be use your statistical knowledge, statistical tool. Okay, and you have to do the analysis of that data, and you have to present it on National Statistics Day. Okay, so those students who are interested for that, you can have a minimum of 3 to 5 ka group. Okay, we are going to use secondary data, which I said maybe some, but it is going to be relevant information only. Okay, no need of collection of data, because that is all time consuming. That we can do under the visual storytelling. Under that program, you can collect it. But those students are interested for National Statistics Day, they can coordinate your friends. Okay, form a group of 3 to 5. Okay, we will provide you the data. Your job is to do the analysis, which may be the basic of your charts. You can have some type of descriptive statistics. You may have try to fit some model. You may draw some probability distributions. Okay, which you have studied so far. And if you do advanced statistics also, that is also fine for us. Okay, so you can form a group and then let just inform either me or Jay sir. We will provide you data so you can start working on that. Okay? In case if you have any questions, please pass this message to your friends also, because I hope there are only 25 students so far, because they might be have some other work also. So still on 29 we have National Statistics Day. So for that you can start preparing. Means today is around today's 18. So still there are 10 days. So as soon as I will get the group name, I will share the data with those students, those group, and you can start working on. Means what type of analysis you can. Suppose we have male female data, we have gender data. So gender data में हम क्या कर सकते हैं? For example, you can find out you can draw the frequency distribution, how many male and how many female. You can draw the charts. Okay, means whatever analysis you can do it based on that data. Okay, that you can do it, and you can just present it on the occasion on the 29th June, or maybe the date will be decided, then it will be. Okay, so this is all about your National Statistics Day, which is coming. I think notice is going to be come very soon, and continue with. Yes, now I think this is all from my side.